Hello dear students. In a previous class we have discussed about the force of the particle, acceleration, velocity, those particles executing the simple harmonic motion. In today we'll discuss uh, what will be the general form of the particle where it is executing the simple harmonic motion, and the displacement of a particles is in detail how we can be expressed it is in the form of, or how we can understand in the form of particle is executing the simple harmonic motion. So the simple harmonic motion, once again I will write it here, that is of to and fro motion here, that is of to and fro motion. Already we know about this, what is the simple harmonic motion, that is of a special case it is, or else we can say this is a specialized form of a simple harmonic motion, or else the oscillatory motion it is, oscillatory motion. So those things you have to understand in a clear manner here. As we know, once again, if you go ahead with the simple pendulum, this is the mean position where its velocity is a maximum, and before going to that, this position we can say that x is equal to 0 it is. Once again I will write it in a bigger form. So when it executes the to and fro motion, that is of extreme position here, right, where this is x is equal to positive direction here, right, and once it moves to the another extreme position, so x is equal to negative here. That means the maximum displacement from the mean position is amplitude, that we know already here, that is of positive here in this direction, and this is of a negative amplitude here, because with respect to the mean position of a particle, its displacement is taking place negative side, means opposite to the direction of another side of the extreme position. So it will tells you to and fro motion. So the particle execute the force which makes an body to, or a particles to move towards the mean position it is, that we know here. Force is also we have to understand here, and acceleration along the direction of a force here. So body is doing the displacement here, or the velocity here, so it is trying to meet or move towards the mean position along the direction of force only. So here force which experienced by the particle is opposite to the direction of displacement, as we have studied in the motion of a particle in a straight line. Displacement and force is along the direction of displacement of a particle here. And in this case of simple harmonic motion, in short form we are writing here SHM. In this form of oscillation, body executes the to and fro motion. That force which is experienced by the particles to move towards the original position, I mean to say that mean position, where its velocity is a maximum. In extreme position, velocity is a minimum here. It is in a minimum. So velocity is a minimum here. So velocity is a minimum, or it is equal to 0 at the extreme position of a particle here, right? As we know, F is equal to minus kx raised to n here. Acceleration is a maximum here, as force is also maximum at the extreme position. So we are going to understand here what is the equation of the particle when displacement taking place at the positive direction from the mean position. What is the general format? Or if the particle is in between the extreme position, what will be the equation of the particle? So obviously the particle executes the to and fro motion. So we need to understand how it can be studied in the form of equation here. So that is very important here. So as we know the velocity of the particle, we know here v is equal to omega root of a square minus x square here. So x we know what is that? Displacement, or x always measured from mean position. This part we have to repeat it again and again, or I'm repeating so that x should be measured from always mean position of a particle. We'll get to know that why it is stretched again and again in the upcoming topic there. So we know as velocity of a particle is omega is equal to, sorry, v is equal to omega of root a square minus x square. So let us call this as equation 1 here, right? So we know v is equal to dx by dt here. So dx by dt. So in place of v I will write it here dx by dt. That means differentiation you have to do on both the side here. Both the side means we know already here what is v, dx by dt. It is d by dt of x. X is what here? Displacement is taking place when the body executing the velocity, means moving from the mean position to the either side of the extreme position. Either it is a positive extreme, either it is a negative extreme. So we are considering here positive extreme so that it is easy to understand first how it is behave. Later we can apply to the negative form. It is easy to understand. So root of omega of root of a square minus x square here, right? So what will be the next form here? Dx by dt is equal to right, omega. I will take it outside here. So what is remained here? A square minus x square. So we know that v is equal to dx by dt here. I will just place it in the form of v here, dx by dt, that is of omega of root a square minus x square here, right? This will be shifting here. That means dx I will take it down, root of a square minus x square, right? Then omega dt. So let me call it as this is a equation 2. Means dt is shifted here. This part I have taken into this side. So looking at this equation, we have to integrate this equation 2. Integrate. Why we need to integrate here? So we want velocity, I mean to say that general form of displacement of a particle from the mean position when it is executing the simple harmonic motion. Integration will give you the simplest form or easier, very integrated manner. Means a simple form we are getting, single form we are getting how the particle is showing the displacement. So integrate of dx by root of a square minus x square, right? So integration of dt, integration of dt. Now we'll understand the next form here. Body is moving and showing the displacement. Here I'm using the body, or else you can take a particle also. So particle is there in the mean position. It is showing the displacement for the positive extreme position here. So here x will be 0 and moving towards to this position, extreme position, x will be a here. Similarly, t is equal to 0 at the mean position and it is moving after certain time t here. That means displacement is there here because x is there in this form. So it is moving from 0 extreme position, it is mean position to extreme position here. That means 0 to x here. So 0 to x I will take out. So here it is x is equal to 0 only. Here I will take it x is equal to x only. Not in the same of, it is not moving completely extreme position. It may be certain distance. It is understood x is equal to a only. That means it is moving for the extreme position here, right? 0 to x. Similarly, t is equal to 0 to t, because which is variable here in this second part here? T is variable. That means time period 0 to t here, right? So what kind of this is? This is a limit. Limit means in this range only the particle plays the game here. So it is moving this side, again it is moving. That is first oscillation, second, third and fourth. In simple harmonic motion, 4 stages will be there here. So we will discuss in the one by one, right? So I'll just remove this one to solve this equation. But you should remember this diagram as I am writing on the bold here. So before going to the expression of this next part, I have explained how it is moving. Right. So integration of 0 to x dx of root of a square minus x square is equal to integration of 0 to t omega dt here, right? This omega we will discuss what does it mean in the next upcoming classes. So now until then you just concentrated this part. So can you able to see this form? This is a general form of integration here. I will write it here, integration of dx of root of a square minus x square can be written as sine inverse of x by a. It is directly we can write it here. We can't derive this expression. What is the integration of dx by root of a square minus x square? This you are going to study in a mathematical class, that is in the chapter of this one, integration. Detailedly by using this expression we can directly enter here sine inverse of x by a. So this part you have to remember. So when you will get the expression or a derivation of this form, how it will be equal to sine inverse of x by a, you can study it in your mathematical class. Now let us move ahead. Instead of this, I am writing here sine inverse of x by a. What is the limit here? Means the displacement of particle mean position to the certain distance from the mean position, right? That is of maximum displacement from the mean position here, right? So this form I'm going to write it here. So a square minus x square, it can be written as a sine inverse of x by a directly. Now integration of this, so plus or minus omega integration of dt here, right? So that is of equation number 3 here. Now sine inverse of x, in place of x I will put it here because this is the first limit here, this is the second limit. That means initial to final. First you have to go ahead with the final, subtraction of initial limit here. So x by a minus of sine inverse of 0 by a, right? So that is of omega t. Here it is t, it will comes. So you can write it here 0 to t. So directly I will write it here. That is of t minus 0. Omega t only, it will get it here. That means sine inverse of x by a here. This part, sine inverse of 0 by a. the whole thing sine inverse of 0 will be 0 only you are getting. So minus 0, that is of omega t here, plus or minus omega t. So what you are getting here, next form, sine inverse of x by a. So sine inverse of x by a is equal to plus or minus omega t. So we have got it here. Now this sign I will convert it to here, means I will send it to there, that is x by a is equal to, inverse will comes into the form of sine omega t here, right? So I will send this x is equal to a sine omega t. So here I will write it plus or minus. That means this is the general form of the particle execute the simple harmonic to and fro motion. So if you want, you can just cross check with the diagram here. Simple pendulum, bob is there at the mean position, right? Just to cross check. So this will be the extreme position when it is moving here. So positive direction means x is moving from 0 to certain distance here. So x is positive here, so that this journey, this part is a sine omega t, because it is a positive direction. When it moves towards the another extreme position here, x is negative. So x is negative means minus a sine omega t. So you should remember here, particle is moving from mean position, means at x is equal to 0 to positive direction of the displacement, that is a sine omega t here. When it is moving towards the negative direction, that is minus a sine omega t with respect to mean position. Why am I using this point here, means it is not compulsory that body should move from the mean position only. It may start the simple harmonic motion, means to and fro motion in the extreme position also, in between this mean position and the extreme position. Maybe it is the positive direction, maybe it is a negative direction. So at that time we will get confusion here. So that this equation is there, no, that is for the particle when it is executing the simple harmonic motion at the mean position, means it started the journey to show the to and fro motion exactly from the mean position it is. For such condition of a particle, this equation is executing. And next will come here, what will be the equation of a particle when it is there at the extreme position or in between the extreme position. So this will be the positive sine omega t, and this will be the negative sine omega t here. As I said here, particle, it is not compulsory that it has to show the displacement from mean position only. So as it is moving to the extreme position from the mean position here of a particle, we know that x is equal to what here for the positive direction, a sine omega t here. This y means this is a positive direction it is. So when it is moving towards the extreme position, this is the equation here. And when it is moving to the negative extreme position here, so its x value will become a minus a sine omega t here. When it is moving or it is showing the simple harmonic motion from the mean position where x is equal to 0 and t is equal to 0, where velocity is maximum. As we see in place of writing maximum here, you can write it here omega a square root of a square minus x square plus or minus here. That is understood. Maximum means it is understood here, right? If such particle, this equation we got it here when particle is there or executing the simple harmonic motion from the mean position here. If particle is there in between this journey, means from the mean position also it is not showing the simple harmonic motion, means it is not moving or it is not there in the extreme position. If such case, what will be the equation of a particle? Even though if particle is there in the extreme position, then it is showing the simple harmonic motion. It is not compulsory that particle should show the simple harmonic motion always from mean position. It is not like that. It may show simple harmonic motion from the mean position, between the mean and extreme position, or at the extreme position. We don't have any compulsory action here. Particle may move here. So when will be the position of a particle? When it is under the simple harmonic motion. That is very important here. Same way that will ask the question in a competitive question here. So later we will going to discuss here, right? So consider the particle is there on the extreme position here. So here the particle is there and it is showing the two motion here, right? That means this is the positive direction. Don't tell that this is a negative direction. No, because the particle is there already in a positive direction. It is there at the positive extreme position. Then that point means from that extreme position it is showing the simple harmonic motion. That means two motion and the flow motion. So once it is reaching here, this is the extreme position with respect to the previous extreme position. But the displacement of a particle measure from here. Got it? Why I am saying that? X always measure from the mean position of a particle. Don't measure it from here only. This is not X. So this is the complete journey, because particle first should stay here stable, then it will move to this position. Again from this point it will show the to and fro motion. That's why X always measures from the mean position, or else this position also we can say that a stable equilibrium. Stable equilibrium position it is. Why we have said here at this position the particle is going to be set as an equilibrium on both the extreme position here. So that's why this is a stable equilibrium position or a mean position. Always its X is measured from mean position here. So once it is moving here, it will move to certain distance here. So this position is also positive here, you should remember, because the whole particle is at positive extreme position. So it will move here, come to the original position where it has started the simple harmonic motion or the to and fro motion here, and it will reach to the another extreme position that is also positive here. So we have to understand what is the equation. As we got the equation, x sine x is equal to a sine omega t when particle is moving from 0 to certain distance x here. This is the equation. So what is the x equation here? When the body is moving from x is equal to a means here I will take it as a x is equal to a. That means already particle is there at the extreme position. There it is starting the journey here, right? So from x is equal to a to here, so it is moving from a to x here. X means what here? This is this part, mean position. Y means why it has to move x only here? When particle executing the simple harmonic motion, what is the target here? It has to reach to its original position, right? But particle is at the extreme position. It is moving a certain distance, maybe to the next, or it is moving towards this direction. It is not compulsory, because both the side it is positive only, because the whole particle is at the positive direction with respect to the mean position. So it may reach to here or it may reach to here, but the total target is what? particle, when it shows to here in this direction or in this part here, so next is target is to move towards the mean position if it is moving in this direction. By chance, if particle is moving in this direction, I mean to say that this side, so the journey from here to here, it is trying to reach towards the mean position only. That means this is x is equal to a, and it is trying to move towards x is equal to, I mean, a to x it is. So here x is equal to 0 means it is the exactly mean position it is. From a to x it is moving. Are you getting the clarification here? The particle is there at the, I'll write the diagram once again here. Right, this is the mean position. So this is the mean position where x is equal to 0 also we can say, or x also we can say. So particle is there here where its extreme position it is. So this is the extreme position. So particle is there here. This extreme position I will call it as, this is x is equal to a it is. Once it is showing the simple harmonic motion, it may reach to this side or it may move towards to this side, right? So the displacement is measured from this side it is, or else this. Mean position, x will be measured from here, x will be measured from mean position here. But particle is there at the position of extreme position with respect to the mean point of the particle, or mean position of a particle here, right? So when it is moving in this direction, for the example purpose I am taking this example so that you will get the clarification. If it is there here, right, so it is moving in this direction and it is moving in this direction. Maybe one side it will move with respect to the mean position first. So it may move in this direction or it may move in this direction. It is not compulsory. Here it is negative, here it is positive, because the particle itself is a extreme position of positive direction. This part is positive direction, right? So what will be the general equation of a particle is showing the displacement in positive direction, starting journey from extreme position. Particle is there, right? So in this position, what is the equation here? That is the meaning. We have velocity of a particle. Velocity of a particle is omega is equal to root of a square minus x square. Concentrate here, this is very important. So as we know, x is equal to dx by dt here. Omega is equal to root of a square minus x square. So dx root of a square minus x square here. So I will write it omega dt here. So again you have to do integration here. What you will get? Integration on both the side. Look at the limit here. This is very important here. As in a previous case, particle is moving from 0 to a. I mean to say that 0 to x it is. But in this direction or in this position here, particle is at already extreme position. That means it is moving towards the mean position. That is the agenda here. Whether it is moving in this direction, whether it is moving in this direction, trying to meet or trying to come to its mean position. That's why the force is experiencing on the particle in the extreme position. That you should remember. Force is acting on the particle in the extreme position so that it is moving towards the, what is the mean position, right? So here it is moving from a to x it is. So displacement is a to x it is. Similarly, t is equal to t is equal to 0 here, correct? That means 0 to t it is. Why it is 0 to t here? When this position is stable, it is starting the journey from extreme position, means it has to move here. That is t to 0. From 0 only it has to move to the extreme position. Again it is moving from t to t0 here. So that's why 0 to t here. Here from a to x it is. Again from 0 to, I mean to say that you can say here also. You can take t is equal to 0 because at this position it's starting the simple harmonic motion to where x is equal to 0 here for the example purpose. Example in the sense, before starting the simple harmonic motion, we know that particle is at the extreme position. But particle starts the journey at the position x is equal to a at the time period to show the time to and fro motion or the SHM here, that t is equal to 0 here and reaching to the point t is equal to t here. Now it is understood. So when it is starting the journey, that time we'll take it as a t is equal to 0. So 0 to t it is. So 0 to t. So this concept you have to understand here. Next part here, directly I will write it here. This equation I have written integration of dx divided by root of a square minus x square. I have written here sine inverse of x by a it is. Directly you can write it here. So sine inverse of x by a, what is the limit here? A to x is equal to plus or minus omega t 0 to t it is. Right? Now I will erase this part. Only this part I am going to erase here. Right? Sine inverse of, directly I will put x by a minus sine inverse of a by a it is. Right? So a by a, once again I will draw it while explaining. So let me complete this equation. Plus or minus omega t minus 0. So sine inverse of x by a minus of sine inverse of 1. So it get cancels, remains with 1 here. So plus or minus omega t here, because sine t is 0 is 0 only. Now concentrate here. Sine inverse of 1 means what? Sine inverse of 1 means what? Pi by 2. Correct? So sine inverse of 1 is pi by 2. Pi by 2 is what? 90 degree. So I will write it here directly. Sine inverse of x by a minus pi by 2 plus or minus omega t here. Plus or minus omega t. So sine inverse of x by a omega t plus pi by 2. Next, I will transfer this sign to this side. That means x by a is equal to sine of omega t plus pi by 2. Right? So as we move here, x is equal to a sine of omega t pi by 2. Right? So how it is? This is in the form of sine theta plus something else. Maybe it is pi by 2 is 90. Sine 90 plus theta. So in sine 90 plus theta means what? 0, 90, 180, 270, 360. So sine 90 plus theta. So in this direction, all students take coffee. So sign is positive. So but here in this perpendicular or a 90 to 70, sign will changes into next form. That means x is equal to, so what is that? X is equal to a will be remains, sine 90 will changes into cos omega t here. So what is this? Cos omega t here. So this is the general equation of a particle when it is at the position of extreme position, showing the to and fro motion, or between the mean position and the extreme position. To understand this here, I'll write it the one more time, the diagram. So just concentrate here. So this is the mean position. Its extreme position is this one. So we have taken the particle here where its position x is equal to a here. I have shown it is moving certain distance here and it may move certain distance here. We got the expression here when particle is there at the extreme position, x is equal to a cos omega t here when it is moving in this direction. So when it is moving in this direction, that time also x is equal to a cos omega t here, right? This is of a cos omega t. Why? Means it is moving from a to x, means it is moving from a to x, from the extreme position to mean position, where it is started the simple harmonic motion or a to and fro motion at a time t is equal to 0 to t here. So this diagram you should remember when particle is at the extreme position, and particle may be within mean position and the extreme position. That time also this is the same here, a cos omega t, this side and this side. When, this is very important, when particle is there at the negative extreme position, here x will be minus a. What will be the general equation? That we are going to study in the next class. So before going to this part, you have to understand this concept here, because this is nothing but one of the synopsis to solve the numerical problems and the competitive problems. They may ask the question, what is the equation of a simple harmonic motion of a particle when its journey or when it is at the extreme position, or certain time period or certain amplitude may be given, a is equal to 2 second, 2 centimeter or the 4 centimeter. That we are going to discuss in the upcoming classes.